Hello Python students. In this tutorial, we will see functions, or in fact more precisely, user-defined functions. First problem statement. Write a Python code using functions which calculates the number of uppercase letters, lowercase letters, total number of characters and number of words. Here, few test cases are given. Each given test case specifies a statement regarding functions. For example, test case 1, functions could have no parameters. In this case, the expected output is 1, 29, 34, 5. In the same order as mentioned in the problem statement. 1 uppercase letter, 29 lowercase letters, 34 number of characters and 5 total number of words. Now looking at these numbers, one may wonder why number of characters are higher than the sum of uppercase letters and lowercase letters. This is because when we count number of characters in a sentence or in a string, we count special characters including space between two different words. Now let's write a Python program with functions which will calculate all these different characteristics of the given input. We will accept an input from the user and store it in a variable called sentence. This sentence variable will store the entire input as a single string. For example, in case of first test case, the sentence variable will store a string and the value for that string will be functions could have no parameters. Now next part is to write a function to calculate total number of uppercase letters in the given input. Let's write one function called upper. To this particular function, we will pass this particular variable sentence, and this function is supposed to return back the total number of uppercase letters in the sentence, which can be stored in a variable uletters, as in uppercase letters. Once we have the total count for uppercase letters, we can print it using formatted printing. But the most important part with respect to this particular code is to write this upper function. Now let's see how this function can be written. As we have studied earlier, in Python a function is written using keyword def followed by function name followed by list of parameters. In this particular case, we will call a function upper, will pass this particular parameter sentence. Whatever value which is stored in this variable sentence will be passed to this particular variable s, and in this particular function upper, we can use this variable s to do our computation. Now let's look at the logic written inside this particular function upper. We are declaring one variable called upper, initializing it to 0, which makes it integer variable. This particular variable will be used to store the total number of uppercase characters in this sentence. Then we will use this for each feature of for loop, which will iterate over the string character by character. Therefore, this variable c will hold one character at a time from string variable s. Every time value in variable c updates, we will check whether c is upper or not. Over here, is upper is a library function which we have studied earlier. This particular function will return true if value in variable c is a uppercase letter. Otherwise, it will return false. Whenever this particular function call returns true, we will increment the value of variable upper. Now, this particular operator might look odd but it is referred as shorthand operator, which means upper is equal to upper plus 1. This is easier way to increment the value of any variable, which means we will increment the upper variable every time when C dot is upper returns true. At the end, we will return the variable upper when for loop terminates. This particular return statement will return one integer value back to the place from where this function was called, which is over here, which means now whatever value was there in this particular variable upper is now stored in this particular variable u letters, which then can be used to print the uppercase letters along with the message which says total number of uppercase characters. Next part of this particular problem statement is to find lowercase letters in the given input. Just like the code which we return to find uppercase letters, we have to write similar code to find lowercase letters in the given input. So the first step, we will declare one variable L letters as in lowercase letters and initialize it with a function call which says lower, and will pass this particular input sentence as a parameter to that particular function. Once we get the value of lowercase letters in the given input, we will print that particular number along with the message which says total number of lowercase characters. As we have seen earlier, the most important part with respect to this particular code is to write this particular lower function. Let's try to write that particular function. Just like upper function, we will define one function def lower and s as a parameter which will store the input which is coming from sentence. Then we will iterate over that sentence character by character using for each functionality. Then in if block, we will call another library function is lower. This particular function is exactly like what we did earlier using is upper. Only difference is this particular function returns true if the character is a lowercase letter. If that is the case, then we will increment the variable lower. Once the for loop terminates, we will return the variable lower which holds the total number of lowercase letters in that particular sentence, which will return back this value to this variable L letters which can be printed. Now, as per the problem statement, we have to count total number of letters in the given sentence. Let's try to do that as our next function. Total number of characters is equal to character function with a parameter sentence, which means now we have to write one function called characters which will count the total number of characters in the sentence, and it should return back total number of characters which can be then stored in this particular variable chars, and then we can print it along with the message total number of characters and the value, once again using the formatted printing. Let's write that particular function characters. If you compare this particular characters function with lower or upper, you will see it is very similar, except there is only one change, which is this particular if block is missing, because now we have to increment this variable chars every time for every character in the sentence, irrespective of whether it's a lowercase character, uppercase character, a space, or even a special character like comma, full stop, etc. Once again, when this particular for loop terminates, we will return the count which is stored in variable chars back to this variable chars, which will get printed. Now let's move to last part of this particular problem statement, where we are supposed to count total number of words in the given input. Once again, we will declare one variable words, and against that we will call one function called words, which will accept this input sentence as a parameter, and then we will print the total number of words using formatted printing. Let's try to write that particular words function. Over here, we are declaring one variable words and initializing it with 1 instead of 0, because any sentence will have at least one word. Then once again we will use this for each functionality of for loop. Then we will use this particular if condition, which is very interesting because it is checking the value of character against these empty quotes. But if you observe carefully, there is a space between these empty quotes, which means we are actually checking whether the value stored in this particular character is space or not. If the value which is stored in this character is space, which means the if condition is true, then we will increment variable words, which means whenever we encountered a space, we will increment words, because space indicates that the previous word finished and a new word is going to start. Once again, we will return this particular variable words, which will return back to the function call, and the value of words variable over here will get updated, which can be used to print the actual value using formatted printing. Now let's try to execute this code using the given test cases. Let's execute the first test case. Functions could have no parameters. Total number of uppercase characters 1, lowercase characters 29, number of characters 34, number of words 5. Second test case, functions could have no return value. 31, 0, 36, 6. Third test case, functions could have multiple return statements, but the moment the first return is executed, control exits from the function. 19, 86, 125 and 19. Fourth test case, functions have to be defined before they can be called. The function call cannot come before the definition. 26, 63, 107 and 18. Then the last test case, function calls could be used in expressions. 36, 1, 43, 7. As we are getting all the expected outputs for the given test cases, let's move on to next problem statement. Second problem statement, write a Python code using functions to calculate area and perimeter of circle and rectangle. In this particular statement, we have to calculate two different properties, perimeter and area of two different polygons, circle and rectangle. If we look at the test cases, the program expects us to take polygon name and the property of the polygon as input, along with either a radius or a dimension of the rectangle. Depending on these inputs, we are supposed to calculate the respective property and print the result. For example, if input is circle, area and 7, then the expected output is 154 square units, because a circle with radius 7 units will have area as 154 square units. Similarly, if we looked at the second test case, the input is circle, perimeter and value 7. The expected output is 44 units. In this case, we are supposed to calculate perimeter because it is mentioned in the input. Similarly, in test case 3 and 4, the first level of input is rectangle and then the second level of input is the property of that rectangle, either its area or a perimeter. Then, based on the values for length and breadth, we will either calculate area, which is 150 square units, or perimeter, which is 50 units. Then the most interesting test case over here is the fifth one, which says if the input is exit, then the expected output is to stop the execution, which means whenever we enter an input as exit, it should stop the execution of our Python program. Based on these test cases, we can figure out that this is a different type of program as compared to what we have seen earlier. And this particular type of program is called a menu driven program, where a standardized menu will be given to us and we have to choose a particular option from the given menu, and based on that option a specific function will be executed from the Python code. Now let's try to write the Python code for this particular problem statement. First, we will start with a standard program without any menu. Then we will try to convert the standard program into a menu driven code. Now let's look at this particular Python code, which is a standard approach or approach 1, where we will not have any menu. First, we have declared one variable pi and we have assigned value as 22/7. Then we have returned 4 different functions. First, to calculate area of a circle as pi into r, r being the radius of the circle. Second, to calculate perimeter of the circle, 2 into pi into r. Next one, area for rectangle, which is length into breadth. Next, perimeter of the rectangle, which is 2 into length plus breadth. In order to call these 4 different functions, we have accepted the value for radius from user. Then using that particular value r, we called this function circle underscore area. Whatever value it returns, that will get stored in variable C area, and we will print it using this particular formatted print statement. Similarly, we will call circle underscore perimeter function, which will calculate the perimeter of the circle with the given value for radius. Calculated result will be returned to variable C perimeter, and then we can print it using this particular formatted print. For rectangle, we will accept 2 different values from user, first being length and second is breadth. Once both these values are available with us, we will call this particular function rectangle underscore area with those 2 values L and B as parameters. The computed result will be returned back to this variable r area, which we will print over here. Next, we will call rectangle underscore perimeter function with those same values L, B, which will give us the perimeter of that particular rectangle in variable r perimeter, which we will print last sentence. As you can see, this is a standard code where no menu is being displayed, which will ask a user to enter these kind of inputs which says circle or area or rectangle or perimeter and so on. In order to achieve this particular problem statement, we have to make some modifications into this particular standard code and include this particular feature called menu driven program. Now let's try to write a Python code for that particular program. In this approach to menu driven code, we will retain these 4 functions as it is and we'll try to write a print statements in such a way which will print the menu and also indicate the user to enter the right choice from the given list of options. In this case, the first level of option should be whether the polygon is circle or rectangle, or do we want to exit the code. Let's create a structure where we will ask the user to enter the name of the polygon or the word exit if user wish to stop the execution of the code. In order to achieve that, first we will declare one string variable called polygon and will initialize it with an empty string. Then, as we discussed earlier, this particular program should continue its execution till user enters a specific keyword which is exit. Therefore, we will write our code inside a while loop which will continue to execute till the value of variable polygon is not equal to exit. After this, as discussed, first we have to print a menu which will have list of options from which the user can choose a specific polygon or exit. This print statement will print those different options, polygons, and the options are circle, rectangle or exit. Then we will ask the user to enter the value for variable polygon. Input, choose the polygon type or exit. Based on the input given by the user, we will check if polygon is equal to circle, then do something. Else if polygon is equal to rectangle, again do something. Else if polygon is equal to exit. In this case, we will break this particular while loop and terminate this Python code. And the last option is else, which says please select the correct polygon type or exit. This particular else block is required because user may enter a wrong input for this particular statement which is not a part of the given list of inputs, which means we are asking user to choose only one option out of these 3 given options, which are circle, rectangle or exit. In case if user selects a different option which is not available in the given list, then this particular else block will execute, which will indicate the user that the given input is incorrect and the correct input has to be provided in order to execute the program. Now the next step is to write a Python code for a polygon is equal to circle, which means if the user selects polygon as a circle, then we have to move to next level of menu where we are supposed to ask a different properties of a circle, a menu which has 2 different options, area and perimeter. Now let's add that particular code block inside this if. As a next step, first we will declare one variable called property and initialize it with an empty string. Just like a polygon variable, this property variable will be used to accept an input from user, which can be either area or perimeter. Then we will accept the value for radius. Once that value is there, we will execute this particular while loop till the value of property is empty. This particular loop will print the second level of menu, which says circle properties. First option area, second option perimeter, or we can go back to previous menu. Now we will ask the user to select one option from this second level of menu, which is circle properties. If the user selects area, then we will do something. If user enters perimeter as a property, then we should do something. If user selects property as back, which means we should terminate this inner while loop, which is printing second level of properties, and we must go back to original while loop, which is printing first level of menu for polygons. Once again, a else block in case if user enters an option which is not available in the given menu, which will print an indication message to the user which says please select the correct polygon property, and we will reset the value of variable property back to empty string. Now we know what we are supposed to do when a property is equal to area. In this case, we should do exactly what we did earlier, which is to call this particular function circle underscore area, and then we should print the result. But in addition to that, once again we should reset the value of property to empty string in order to accept the next input. Similarly, if the user selects property is equal to perimeter, we should execute this particular function circle underscore perimeter and print the result, along with resetting this particular variable property. Now, as our sub menu for circle properties is ready, we should create similar sub menu for rectangle properties as well. Else if polygon is equal to rectangle, accept length, breadth, then till property is equal to empty, we will print this particular menu rectangle properties, first option area, second option perimeter, third option back. Then we will indicate the user to enter the input. If the input is area, we will call this function rectangle underscore area exactly like what we did over here, and then we will print the result. Similarly, we will do it for perimeter of the rectangle. In this case also, we have to reset the value of variable property every time in order to execute this particular while loop, which is printing this second level of menu which says rectangle properties. Then if user selects back option, we will terminate the inner while loop. Else we will indicate the user to select the correct polygon property. This is how a standard program can be converted into a menu driven code, where the main logic which is written in the functions stays as it is. Only change happens with respect to various print statement and input statements. In this code, we have not yet declared this particular variable pi as 22/7, because as we have improved the code from approach 1 to approach 2, let's try to improve the accuracy of variable pi as well, which can be achieved using an inbuilt library called math. This particular math library has predefined the value of variable pi, which can be used using math.pi. Now we will use this updated value of pi, which will give us a more accurate result with respect to area as well as perimeter. Now let's try to execute both the programs, first using the standard approach, then using the menu driven code. Enter the radius of circle 7, area of circle with radius 7.0 equal to 154 square units, which is correct. Perimeter of circle with radius 7.0 is equal to 44.0 units, which is again correct. Enter the length of rectangle 15, breadth 10, hence the area is 150 square units and perimeter is 50 units. All these numbers are correct, but over here as a user we are not getting an option to decide whether we want only area or only perimeter or only properties of a circle or a rectangle. All these different options are not available with us. In order to achieve that, we will move to second approach, which is a menu driven code. First level menu, polygons, circle, rectangle, etc. Let's choose circle. Then it will ask us for the radius of the circle. Once the radius of circle is in place, then the second level of menu will be printed, which has circle properties. First area, second perimeter, or we can go back. Let's try area first. Now if you look at this particular value, we are getting more accurate value because we have used this particular math library to initialize variable pi. After this particular output, you can observe that the same menu is getting printed once again, and the program is asking us to select the circle property once again, or we can go back. Let's try for perimeter. Now to check the properties of rectangle, we can go back from here, which will display the first level of menu, which has different polygon options, circle, rectangle, or we can exit. Let's choose rectangle. Enter the length of rectangle 15, breadth 10. After this, it will print a second level of menu, but this time it will be a rectangle properties because we selected rectangle as an option from the first level of menu. Let's choose area. It will display the value of area. Then perimeter. This particular approach allows us the flexibility to decide which specific polygon we want to select. On top of that, we can also decide which specific property we want to look at with respect to that particular polygon. Whenever we are done with a specific polygon, we can always go back and explore a different polygon. Or we also have an option to calculate area or a perimeter of a circle or rectangle again and again with different radius or different values for length and breadth, because the program will keep executing till we enter a specific word, which is exit. Let's try that option as well. We'll go back from here. Now we are in first level of menu. Let's try exit. The program is terminated. This added flexibility for a user is the main reason to write a menu-driven program. Let's move to next problem statement. Problem statement 3. Write a Python code using functions which checks whether the input coordinates form a triangle or not. In the given test cases, the x and y coordinates of each point are given to us. Based on the coordinates of these 3 points, we have to decide whether they will form a triangle or not. Mathematically, there are many ways to identify whether the given points can form a triangle or not. For the purpose of demonstration of this Python code, we will write a code using 2 different approaches. First approach will use the distance between the points. Second approach will focus on slope of lines drawn using the given points. Let's look at the Python code using the first approach. First, we have to accept these x and y coordinates for 3 different points, which we will do using a variable x1, y1, x2, y2, x3, y3, using float of input of enter x or y coordinate of first, second or third point. Once we have coordinates for all 3 points, then the next step is to find a distance between each pair of coordinates given to us. We have to calculate distance between coordinate 1 and 2, then 2 and 3, and at the end between 1 and 3. Which means we have to execute same logic 3 different times to calculate the distance among these points, which motivates us to write a function called distance, which can be called 3 different times using different parameters. For example, for first distance d1, we will pass parameters x1, y1, x2, y2. Similarly, for second distance, we can pass parameters x2, y2 and x3, y3. And then for third distance, x3, y3, x1, y1. Now, as we have decided that we will create a function called distance, which will calculate the distance between the given 2 coordinates and return the value back, which can be stored into variables d1, d2 and d3. Let's look at that particular function which calculates the distance. As we all know, a distance between 2 coordinates can be calculated using this particular formula. As we have studied earlier, this particular operator is used to calculate the exponential value of given number. First, subtraction will happen. After that, we will do a square of that result. Similar will happen on this side. After that, we will do a summation of those 2 computed results. Then we are doing power of 0.5. Once all 3 distances are calculated, then we will use the triangle property, which says if sum of 2 distances is greater than third distance, then it is a triangle. But we don't have to check this property for all different combinations, because if we check that the sum of 2 smallest distances is greater than the other distance, then definitely it will be a triangle. In order to do that, first we have to compare these 3 distances to find which distance is the highest one, which can be done using this kind of a logic, where if d1 is greater than d2 and d1 is greater than d3, which means D1 is the highest one, or else D3 is the highest. Else if D2 is greater than D3, then D2 is the highest distance, else D3 is the highest distance. Once we know which distance is the highest distance, then we can write one function called isTriangle, which will find whether D2 plus D3 is greater than D1 or not. Let's try to write that function. This particular function, isTriangle, will accept three different distances. First parameter will hold the highest distance, whereas second and third parameter will hold the remaining two distances. As we seen earlier, if sum of two smaller distances is greater than the longest distance, then definitely the given coordinates will form a triangle. Let's test this particular code against the given inputs. Enter x coordinate of first point 0, enter y coordinate of first point 0, enter x coordinate of second point 0, enter y coordinate of second point 1, enter x coordinate of third point 1, y coordinate of third point 0. We got the distance between all these 3 points, and we can see that it forms a triangle. Let's execute the code using remaining test cases. -3, -5, -7, 10, 0, 0. Again, it will form a triangle. 1, 2, 1, 10, 5, 2. Once again, it will form a triangle. Fourth test case, 1, 1, 2, 2, 3, 3, not a triangle. Fifth test case, 2, 3, 3, 2, 2, 3. Once again, not a triangle, because here a same coordinate is given at twice, which means we will get a line, not a triangle. Last test case, 0, 0, 10, 0, 0, 0.0001. Once again, it will form a triangle. Now let's look at the second approach, which uses the slope. Once again, we will start by accepting x and y coordinates of all 3 points. Once these coordinates are available, we will try to find a slope between the given coordinates. In this case as well, we can draw 3 different lines. Hence, we have to calculate the slope of 3 different lines, which will again motivate the use of function to calculate the slope of a line. Slope S1 is equal to slope between x1, y1 and x2, y2. Similarly, slope S2 between x2, y2 and x3, y3. And then slope S3 is equal to slope x3, y3, x1, y1. Next step is to write this particular function slope. As we know, the formula to find the slope of a line is yj minus yi divided by xj minus xi. If xj is not equal to xi, but if xi is equal to xj, which will make denominator 0, then we can use this math library once again, which has a way to return infinity using math.inf. Once this particular function executes using 3 different combinations, we will get slope S1, S2 and S3. But if we think carefully, we will realize that if the slope of any 2 lines is equal, then it cannot be a triangle. Hence, we don't even require the value of third slope to figure out whether it will form a triangle or not. Hence, we can remove these 2 lines and check whether S1 is equal to S2 or not. If S1 not equal to S2, then it must be a triangle, otherwise it will not be a triangle. Let's try this Python code with the given inputs. Let's try this Python code with the given test cases. 0, 0, 0, 1, 1, 0, it's a triangle, -3, -5, -7, 10, 0, 0. Once again, it's a triangle, 1, 2, 1, 10, 5, 2, triangle, 1, 1, 2, 2, 3, 3, not a triangle, 2, 3, 3, 2, 2, 3, not a triangle, 0, 0, 10, 0, 0, 0.0001. Again, triangle. As we can see, both these approaches are given the expected output. It depends on the programmer to decide which approach to choose in order to achieve the given problem statement. With respect to both these approaches, we can say that these 2 Python codes has same interface but different implementation. Now, based on the Python code which we saw in these 3 problem statements, we can comfortably say that writing some part of the code as a function was very helpful, because in this case we had to calculate distance 3 different times. We avoided writing same code thrice by putting the common code into a function. Similarly, we avoided writing same code to calculate slope twice, because we added that common code into a function. If we go back to previous question, in this problem statement, functions help us in 2 different ways. First, it allowed us to create a menu driven code, and second, it also gave us a flexibility to always add more polygons or more properties of the polygons. For example, if we decide to add a 3D polygon, then we can always add a surface area or a volume and so on. Similarly, in first problem statement, we can always add some more properties for the sentence, like how many vowels are there in the sentence, or how many special characters, or how many sentences are there in the given input, and so on. Hence, we can conclude that function allows us to update the code without affecting the existing program. Thank you for watching this tutorial. Happy learning.